We're going to be looking at what we call long division of polynomials, and then we'll begin looking at a method called synthetic division. And in long division, what we're simply doing is trying to find out if something is a factor. So if we took the problem x squared plus 14x plus 45, and we wanted to divide it by x plus 9. Now, sometimes our divisor will be a factor, and sometimes it won't. But if you remember back when you learned first to do long division, you had a process that you went through. You divided, then you multiplied, you subtracted, and then you brought down. And those were the steps that you would go through as you used your long division. Well, we're going to do the same thing as we go through this, and we're going to do our long division. So we're going to write our dividend, x squared plus 14x plus 45. We're going to divide it by x plus 9. Now, what we do here is we just try to divide our leading term into the leading term of our dividend, the leading term of our divisor into the leading term of our dividend. Just like in long division, sometimes you would just estimate how much it would go in there. Don't worry about the plus 9. We will take care of that as we do our multiplication. So you're going to ask yourself, x times what is x squared? Or you can say x squared divided by x is what? Now you have to make it go in there exactly. And so at sometimes you may end up having to deal with some fractions on that part. But it has to be exact. Now we're going to multiply. So x times x is x squared. X times positive 9 is 9x. Now, in this case, we're going to subtract, and I'm going to put that in parentheses for right now, and we're going to subtract. Well, when we subtract a binomial, if you remember, we have to distribute that negative sign. And when we remove those parentheses. And so if we distribute our negative sign, then this will be a negative x squared, and this will be a negative 9x because the signs are going to change. So we're going to distribute that negative sign, and then we're going to add. X squared plus negative x squared is 0. This should always turn out to be 0. 14x minus 9x would be 5x. Then we're going to bring down. Now we're going to start all over. X times what is 5x? Well, times a positive 5. 5 times x is 5x. And 5 times 9 is 45. Now, I'm not going to put the parentheses here, but this is understood to be in parentheses. When we subtract and we remove our parentheses, then we have to multiply by a negative. So that would be a negative 5x and a negative 45. If you wanted to look at it this way, if we had this written 5x plus 45 minus 5x plus 45, well, we would remove our parentheses, so we would have 5x plus 45. Then we would distribute that negative. So negative 5x minus 45. And when we combine our like terms there, we would get 0. Now, it's going to be special whenever you get 0 as a remainder. Then that means that your divisor was a factor and your dividend, your quotient was also a factor. So this one was factorable. And we could have had it factored as x plus 9 times x plus 5. And so it's going to be special to us when our remainder is 0. Well, let's look at another one. Let's say that we want to divide 7 minus 11x minus 3x squared plus 2x cubed divided by x minus 3. Now, when we go to do our long division, we want to put things in descending order. It makes everything a lot easier. If it's not in order, then you need to put it in descending order. So we're going to do 2x cubed minus 3x squared minus 11x. Remember, the sign goes with the term that follows it, plus 7. That's our dividend, divided by x minus 3. Okay, now we're going to divide. And I like to ask it as what times? X times what is 2x cubed? Well, times 2x squared. If you don't like that, then you can say 2x cubed divided by x would be 2x squared. Then we're going to multiply. So 2x squared times x is 2x cubed. 2x squared times negative 3 is negative 6x squared. Okay, we're ready to subtract. And remember, it's as if we're subtracting and we have parentheses here, so we have to remove those parentheses and that will change our signs. Now when we go to combine these, we get 0 and we get 3x squared. You should always get 0 here. If you don't, then you've made a mistake and you need to go back because you have to make this x go in here exactly. So we bring down the next term. Well, x times what is 3x squared? Well, 3x, and the signs are the same, so it's a plus 3x. Then we multiply. 3x times x is 3x squared. 3x times negative 3 is negative 9x. We're ready to subtract, so we have to remove our parentheses, and that will change our signs. We get 0. Negative 11x plus 9x is negative 2x. We bring down the next term. Well, x times what is negative 2x? Well, negative 2. Negative 2, then we multiply. Negative 2 times x is negative 2x. Negative 2 times negative 6 is positive 6. We're going to subtract, so we have to remove our parentheses, and that will change our signs because it's a negative in front of the parentheses. Then when we combine our like terms, we get 0, and 7 minus 6 is 1. So we have a remainder of 1 in this case. Now, the way that we would write this is we would say plus 1 over and our divisor, x minus 3. The same as you used to do with your fractions. Whatever you got as a remainder, you wrote it over your divisor, and that gave you your remainder. All right, so this is our long division, and you just keep doing this no matter how many terms you have. Now we have what we call a division algorithm, and in that it says that when you have a polynomial or a function, you could actually write it, if you've got a function, then it's equal to the divisor. I'm just going to write this out in words. It's equal to the divisor times the quotient plus the remainder. So your function, which is the dividend, if you wanted to think of it that way, the dividend is the function. So the dividend is equal to the divisor times the quotient plus the remainder. So if we wanted to, we could write this as 2x cubed minus 3x squared minus 11x plus 7 is equal to x minus 3, our divisor, times the quotient which is 2x cubed, or 2x squared, plus 3x minus 2, plus the remainder, which was 1. And so this is what we refer to as the division algorithm. Now, if it divides it evenly, like the previous one that we did, if it divides it evenly, then it means that this was a factor, and each one, both the divisor and the dividend were factors. Excuse me, I said that wrong. Both the divisor and the quotient were factors of the dividend, or our function. So sometimes you'll need to write it using what we call our division algorithm. All right, let's look at another one with long division, and then we will look at what we call synthetic division. So if we wanted to, we would have 2x to the fourth plus 3x cubed minus 7x minus 10 divided by x squared minus 2x. Okay, now when we go to write this, and we're going to write our dividend, what we're dividing, if you notice we have an x to the fourth, an x cubed, then we skip to an x. We didn't have an x squared. When we write our dividend out, we've got to put in an x squared. You have to put in every term as it descends. So we have a 2x to the fourth plus 3x cubed. Now, since we don't have any x squared, what we will put in is 0x squared to say we didn't have any. It's just like putting in a 0 in a number to hold its place. Just like we did here, that holds the ones place. So minus 7x minus 10 divided by x squared minus 2x. Now we go through the same steps. We ask ourselves, x squared times what is 2x to the fourth? Well, 2x squared. We will multiply. 2x squared times x squared is 2x to the fourth. 2x squared minus 2x is a minus 4x cubed. Okay, we're ready to subtract this binomial, so we have to remove our parentheses, and in doing that, our signs will change because we'll multiply by a negative. That gives us 0. This gives us 7x cubed. We bring down the next term. Then we ask ourselves, x squared times what is 7x cubed? Well, times 7x. The signs were the same, so it was positive. We multiply. 7x times x squared is 7x cubed. 7x times negative 2x is negative 14x squared. That's why we needed that when it was to hold the place, because we were going to have an x squared we needed to subtract with. Okay, we're going to subtract a binomial, so we'll remove our parentheses and distribute the negative. That gives us 0. This gives us 14x squared. Bring down the next term. Well, x squared times what is 14x squared? Well, times 14. 14 times x squared is 14x squared. 14 times negative 2 is negative 28x. We're going to subtract, so we have to remove our parentheses and distribute our negative sign. This gives us 0, and this gives us 21x. Bring down the next term. Now, we cannot divide x squared into x. Once your degree here is less than the degree of your divisor, you're finished. So this would be our remainder, so we would write this as plus 21x minus 10 over x squared minus 2x. If we wrote it as our algorithm, we would write it as 2x to the fourth plus 3x squared cubed minus 7x minus 10 is equal to x squared minus 2x times 2x squared plus 7x plus 14 plus 21x minus 10. Now you may just be asked to write the quotient, or you may be asked to write it using the division algorithm. It just depends upon your directions. But that's the same thing. Since our remainder was not 0, then this says this was not a factor. All right, we want to look at now at what we call synthetic division. Synthetic just means that it's been derived, it's been contrived to give you the same results. And synthetic division is really a neat thing to use, and it makes a lot of our problems much easier and much faster to work. It's just you've got to get used to the notation of it to help you. So let's say that we have x cubed minus 7x minus 6 divided by x plus 2. Okay, what we're going to do differently on this is instead of writing this as a dividend, and this is our divisor, we're going to do it just a little bit differently. All we're going to do is write down the coefficients. Now, just like we did with our divisor, and we'll go through and do this one by long division also, just so that you can see how you get the same answer. But just like we did with our divisor before, our dividend before, we've got to have a term for each power as we descend. So for the x cubed, our coefficient is 1. For x squared, we don't have one, so our coefficient was 0. For x, our coefficient's negative 7, and then we have a constant of negative 6. Now, for our divisor, we're going to put a little symbol that looks like a backwards L. We're going to put our divisor here. Our divisor is what this would be as a solution, or as a root. And what you can do, if you're wanting to know your divisor, you can take this and set it equal to 0 and solve. So x would be negative 2. So our divisor is going to be negative 2. Now, one of the things that has to be true for synthetic division is you can only use it, and we're limited on that. We can only use it if it's x to the first. So that last problem that we did where we had an x squared, we could not do that one by synthetic division. We would have to do it by long division. So there are uses of our long division. So it can only be x squared, and the coefficient has to be 1. So if the coefficient's not 1, then we would have to go through and do some things to deal with that. Now what you're going to do is you're going to leave a space and then just draw a line. We're going to take whatever this number is and bring it down and write it right below the line. Now from here on, we're going to only do two operations. We're going to multiply and add. We're going to multiply our divisor times whatever number we have below the line, and we're going to write it under that next number, but between that number and the line. So negative 2 times 1 is negative 2. Then we're going to add these two together. 0 plus negative 2 is negative 2. We will then multiply again. Negative 2 times negative 2 is a positive 4. Then we will add these two together, and we get negative 3. Negative 2 times negative 3 is a positive 6. We'll add these together and we get a 0. Now I like to draw a line here because this last number is my remainder. And so that way I can kind of distinguish things as I go through. Here I had a remainder of 0. So again, that's going to mean that my divisor was a factor. Now we need to write this then back as a polynomial. Well, think of your powers. You had an x cubed divided by an x. So that means that our answer is going to be an x squared, because when you divide like bases, you subtract the exponents. So these are our coefficients. This is my coefficient for x squared. So I have 1x squared, and then it's just going to be x as the powers descend. Minus 2x, minus 3, and my remainder was 0. So that would be my quotient. Now let's do this one by long division, just so that we see that we do get the same answer. We'd have an x cubed plus 0x squared minus 7x minus 6 divided by x plus 2. And we would say x times what is x cubed? Well, x squared. X squared times x is x cubed. X squared times 2 is 2x squared. We're getting ready to subtract, so we have to remove our parentheses and our signs change. We get 0. We get negative 2x squared. Bring down the next term. X times what's negative 2x squared? Well, negative 2x. Negative 2x times x is negative 2x squared. Negative 2 times 2 is negative 4x. We're going to subtract, so we have to change our signs. Then combine, we get 0. We get negative 3x. Bring down our next term. X times negative 3 would be negative 3x. Negative 3 times x is negative 3x. Negative 3 times 2 is negative 6. We're going to subtract, so we change our signs, and we got 0 as a remainder. So you can see we got the same answer, but it was a lot easier to do. When you can use synthetic division, it will be much easier. But you are limited. You can only do it when you have x to the first power as your divisor and a coefficient of 1. Right, let's go through and do another one. And let's say we've got x to the 5th plus 4x to the 4th minus 3x squared plus 2x plus 3 divided by x minus 3. Now you can see this would be really long if we did it by long division. Now all we do is we write down our coefficients. So we have 1x to the 5th, 4x to the 4th. We have 0x cubes. You have to watch your powers. Minus 3x squares, 2x, 3. If you start with x to the 5th, you have to put down a coefficient for each x as you descend all the way down to your constant. Now, for our divisor, okay, remember to get our divisor is we take this and we solve it. So if we set that equal to 0 and we were going to solve, then we would have x minus 3 equals 0 or x equals 3. It's what that would be as a root because it's our divisor. So our divisor is 3. Now we leave a space, draw a line. We bring that first number down below the line. Now we're going to multiply and put our answer above the line. So 3 times 1 is 3. We add and get 7. 3 times 7 is 21. We add and get 21. 3 times 21 is 63. We add and get 60. 3 times 60 is 180. We add and get 182. 3 times 182 is 546. We add and get 549. Now that last number, remember, is our remainder. Our power is going to be 1 less than the degree of our dividend because we were dividing an x to the 5th by an x. So that's going to give us x to the 4th. So we have x to the 4th plus 7x cubed plus 21x squared plus 60x plus 182. Then we do our divisor the same way, plus our remainder over our divisor of x minus 3. And we've used our synthetic division. Since our remainder was not a 0, then these were not factors. Okay, if we look at one more, we have, and it can be written in different forms. You might have it written as 2x to the 5th minus 3x to the 4th plus x cubed minus x squared plus 2x minus 1 over x plus 2. Well, remember, this is just another symbol for division. So we would write down our coefficients: 2, -3, 1, -1, 2, -1. Notice we had 5, 4, 3, 2, 1 constant. So we didn't have to put any zeros in there. Our divisor is going to be -2. We leave a space and draw a line. We bring down that first number. Then after that, we're going to multiply. -2 times 2 is -4, and we put that above the line. Adding, we get -7. -2 times -7 is 14. We add and get 15. -2 times 15 is -30. We add and get -31. -2 times -31 is a positive 62. Adding, we get 64. -2 times 64 is -128. And adding, we get -129. Okay, for our degree, we had a x to the 5th divided by x, so this is going to be x to the 4th. So 2x to the 4th minus 7x cubed plus 15x squared minus 31x plus 64. And remember that last number's our remainder, so plus -129 over x plus 2. Now we could have also written this one using the division algorithm. So we could have written as our dividend was equal to x plus 2 times this plus the -129. There's one other way that your problem can also be written. And so I want to look at one along that line. It's possible that sometimes you might see it written like this. 5x squared minus 12x minus 8 times x plus 3 to the -1. Well, remember that when we have an exponent of -1, it just means the reciprocal. So this is just another way of saying that we're going to divide it by x plus 3. If we wrote this with a positive exponent, then that x plus 3 would go down into the denominator, and it would look just like this problem. So that's just another way to write that we're going to be dividing it. So we would have 5, negative 12, negative 8. Our divisor would be negative 3. Bring down the 5. Negative 3 times 5 is negative 15. That would give us negative 27. Negative 3 times negative 27 is a positive 81. And so that would give us 73 as our remainder. So we would end up, we had x squared divided by x. So this would be 5x minus 27 plus 73 over x plus 3. So there's several ways that we can write our division problems, but they all mean to divide by it. Now there's some special theorems that we have with our synthetic division that make some very important discoveries. Along with our division, both long division and synthetic division, there's two very important theorems that we use. The first one we're going to look at is called the remainder theorem. The remainder theorem says if a polynomial f of x is divided by x minus c, then the remainder is f of c. Now let's look at what this means. Let's take a polynomial. Let's take the polynomial f of x is equal to 3x cubed plus 4x squared minus 5x plus 3. And what we're asked to do is we're asked to find f of negative 4. Well, if we need to find f of negative 4, then what that means for us to do is take our function, wherever there's an x, plug in a negative 4. That's what we've done before. So we would go through, wherever we have an x, we're going to plug in negative 4. And then we would have to go through, okay, negative 4 cubed is negative 64. Negative 4 squared is 16. Negative 5 times negative 4 is positive 20 plus 3. Well, 3 times negative 64 is negative 192. 4 times 16, 64. Plus 20 plus 3. Then we would have to go through and combine these, and we would add those up, and we'd get negative 105. And that took us a while to do. Now, what this says is if we took this function and instead we divided it by x minus c, then the remainder is what we would have gotten here. Well, let's see. If we took this function, 3x squared, so let's do synthetic division. So that would be 3, 4, negative 5, 3. Now we divided it by x minus c. Well, let's see what that would mean to do. This is c. If we divided it by x minus c, then that means that our divisor would be x plus 4. But if you remember, what we did to get our divisor in synthetic division was we would set that equal to 0 and solve so that x would be negative 4. So we divide it by c. Okay. So we divide it by whatever c is. Now, let's do our synthetic division. We're going to bring down the first number and then multiply. Negative 4 times 3 is negative 12. Plus 4 would be negative 8. Negative 4 times negative 8 is 32. plus negative 5 is 27. Negative 4 times 27 is negative 108 plus 3 is negative 105. Wow, our remainder was the same answer we would have gotten as if we had substituted that number into our function. And this was sure a lot easier than doing all of this work. So that's our remainder theorem, that if you are trying to evaluate a function at a specific number, then what you can do instead is divide it by that number, and whatever your remainder is the same answer you would have gotten by plugging in. So let's look at another problem that way. Let's say that we have that f of x is equal to x to the fourth minus 5x cubed plus 5x squared plus 5x minus 6. And we want to find f of 2. Well, instead of plugging it into all of those numbers and evaluating it, what I'm going to do is synthetic division. So I'm going to do 1 minus 5, 5, 5, negative 6, and my divisor is going to be 2. Bring down the first number. 2 times 1 is 2, minus 5 is negative 3. 2 times negative 3 is negative 6, plus 5 is negative 1. 2 times negative 1 is negative 2, plus 5 is 3. 2 times 3 is 6, plus negative 6 is 0. So that was my remainder. My remainder was 0, so that means if I had plugged it in up here, I would have gotten 0 for an answer. So f of 2 would be 0. Whatever your remainder is the same thing that you would get if you plugged it in. And let's look at one more that way, and then we're going to come back to this problem for just a minute. So let's say that we've got f of x is equal to 3x to the, is just equal to x to the fourth plus 5x cubed plus 5x squared minus 5x minus 6. And I want to find f of 3. I want to know what that equals. Well, instead of plugging it all in and doing all of that, I'm going to do my synthetic division. So I have 1, 5, 5, negative 5, negative 6. I'd made sure 5, 3, 2, 1. So I didn't need to put in any zeros. My divisor is going to be 3. I'll bring down my first number. 3 times 1 is 3, plus 5 is 8. 3 times 8 is 24, plus 5 is 29. 3 times 29, that would be, is 87, plus 5 is 82. 3 times 82 is 246, minus 6 is 240. That's my remainder, so that's what I would get if I plugged it in. So this is one of our uses of synthetic division, and this is called the remainder theorem. Whatever the remainder is that you would have gotten when you divided is the same answer that you would have gotten if you had plugged it into the function. And so you do whichever one is easier. Now, let's go back to this problem. We got a remainder of 0. And so what that leads us then to is our factor theorem. And we're going to look then at the factor theorem. Okay, our factor theorem says that let's let f of x be a polynomial. So all we're looking at now are polynomials. It says if f of c equals 0, then that means that x minus c is a factor of f of x, of our polynomial. And if x minus c is a factor of f of x, then f of c is going to equal 0. Both of these are true. We can go through either way. So back here, if we were looking back at this problem that we had, then we found out that we had a remainder of 0. So that meant that f of negative 9 would have been 0. Therefore, it means that these are factors. And I think if we looked at this problem, there's another one that when we looked at it, in fact, we even wrote it down that way. As we worked it through, we got 0 as our remainder. So that would mean, according to our factor theorem, then that f of negative 2 would be 0. So if we had taken our function and we had plugged in 0 for x, or negative 2 for x, we would have gotten 0. So that means that x plus 2 is a factor of this polynomial. And our quotient is our other factor. So with this, we've got a very important thing that we can do and we can go through and look at. Let's go back and take an equation. Let's say that we've got the equation 2x cubed minus 3x squared minus 11x plus 6. We're wanting to solve it. So we're going to set it equal to 0. And what we're told is that negative 2 is a 0. We know that negative 2 is a 0. We know that negative 2 plugged into here will give us 0. So according to our factor theorem, if we put in a negative 2 into our function, we get a 0. Therefore, x minus c, x minus a negative 2, is a factor of this polynomial, or x plus 2 is a factor. Now, what we want to do is to find the other factors. And we want to solve it. We know one factor, so if we can find the other. So let's use our long division, or our synthetic division. 2 minus 3 minus 11, 6. And we're going to divide it by negative 2. We already know we're going to get 0 because that's what we were told. So negative 2 times 2 is negative 4, negative 7. This would be 14 minus 11 would be 3. Negative 2 times 3 is negative 6 and 0. So that was what we were told. We got 0 as a remainder. So we know that x plus 2 is a factor. And what we have left, 2x squared minus 7x plus 3 is also a factor. Well, now we're down to a quadratic. We know how to solve quadratics. We can either factor or we can use the quadratic formula, whichever one you would prefer. I'm going to factor it just to practice that. Since my coefficient's not 1, remember I multiply 2 times 3 is 6. So I want factors of 6 that add to be 7. Well, that would be my 1 and 6. So I have 1x and 6x. I know my signs are the same. They're both negative. Then I write down my first term. I write down my last term. And I factor by grouping. In this first group, I have a common factor of x. X times 2x. X times negative 1. Minus a common factor of 3. Negative 3 times 2x. Negative 3 times negative 1. I have my common factor of 2x minus 1, x minus 3. If you've forgotten how to factor a quadratic, then you might go back to the video on factoring. So we have 2x minus 1 equals 0 and x minus 3 equals 0. I can add 1 and divide by 2. I can add 3. So now I have all of my zeros for that polynomial. X is 1/2, x is 3, and x is negative 2. Or I have all of my factors, 2x minus 1, x minus 3, and x plus 2 are the factors for that polynomial. If we look at another one, and let me just go back and say this. If you were not comfortable with factoring this, then it is a quadratic equation. You can use your quadratic formula, the opposite of b plus or minus, and go through your quadratic formula there. You don't have to factor it, but we know several ways of solving. So let's solve 3x squared, or 3x cubed, plus 7x squared, minus 22x, minus 8 equals 0. And we're told that negative 1/3 is a root. So again, that's going back. We're being told that negative 1/3 will give us 0 when we divide. So we've got one root. So we'll write down 3. I'm checking my powers, 3, 2, 1. So I don't need to put in any zeros. So my divisor is going to be negative 1/3. Okay, we bring down our first number. Well, negative 1/3 times 3. A third of 3 is 1. Signs are different, so it's negative. A third of 6 is 2. Signs are different, so it's negative. That would be negative 24. And a third of 24 is 8. Signs are the same, so it's positive. So I got a remainder of 0. So that's what I knew I was supposed to get, because I was told that that was a factor. Now what I have left is 3x squared plus 6x minus 24. And I want to simplify this. Well, I could factor this. There's a common factor of 3. So let me factor out the 3 and have x squared plus 2x minus 8. And then, oh, my coefficient's 1. What are factors of 8 that subtract to be 2? Well, 4 and 2. Signs are different. The larger one's a plus. Then I can set each factor equal to 0. I know the 3 doesn't equal 0, so x plus 4 equals 0, or x minus 2 equals 0. Solving, I would subtract 4, so x is negative 4, x is 2. And I was told that x was negative 1/3. So now I have all of my roots, all of my solutions, all of the places where I cross the x-axis. So we have several methods of dividing. We can divide by long division. It will always work. Under certain circumstances, we can divide by synthetic division. And when we can, it's much easier. But the circumstances, if you remember, your divisor has to be to the first power and the coefficient of it has to be 1. And so we're looking then at dividing. And then remember that we have the two important theorems. We have the factor theorem, which simply says that if you get 0 as your remainder, or when you substitute in you get 0, then that means x minus that number is a factor. And the remainder theorem, if we can remember where we put that, the remainder theorem tells us that when we divide, then whatever our remainder was is the same answer we would have gotten if we had evaluated the polynomial at that number. So those are two very important theorems.